beach balls big as the earth. Your lady in bikinis wanna play catch. The hair off the peanuts drip like Keith Sweat. I'm drinking pineapple juice, Grey Goose and Florida.
Okay, so here we're going to find the transition points, the intervals of increase or decrease, the concavity, and the asymptotic behavior. Then we're going to sketch the graph of this function, which is our f of x, okay? Alright, so all of these things, don't worry, because we're going to do all of that anyways to sketch the graph. So let's look at this. So this is our f of x, and what we'll need are the transition points, which is where our f prime of x and our f double prime of x, where they switch signs, right? Those are really important. The intervals of increase or decrease of our function, concavity, that's given by a second derivative, and the asymptotic behavior. Okay, so first of all, let's start by finding the first derivative. So we have f prime of x is equal to 2x minus, and then we have a 12x squared, okay? So this we can simplify it a little bit, right? So if we take out a 2x, we get 1 minus a 6x, okay? So we have something like that. Okay, so now let's just write off, we'll just find the second derivative, and then we'll see where that goes. So second derivative would be 2 minus a 24x, and then we can simplify that into taking out a 2, so then we have a 1 minus a 12x. Okay, so where are our transition points? That would be when f prime of x, well, to have a transition point, our first and second derivatives have to equal 0 or do not exist, right? So let's find where these equal 0. So that equals 0, and that equals 0. So f prime of x equals 0 when we have that x is equal to 0 itself, or if x is equal to a 1 over 6, right? If we solve for x for this part here, okay? And then f double prime of x is equal to 0 if we have that x is equal to just a 1 over 12, okay? So let's do a sign analysis for both of these. So we're going to take these pieces of information. So we found the critical points for both of them, and they could be transition points, but we're not sure yet. Okay, so let's do f prime of x first. So f prime of x is equal to a 2 times x minus 12x squared. Our transition points are 0 and 1 over 6. Okay, so let's form that. So we have our f prime, and we're at 0, and one of them is 1 over 6. Okay, so if we have that, let's pick our easy points. So that'll be like a -1. This one I'll make 1 over 10, which is kind of easy, and then a 1. Okay, so let's plug those in, our test points here. So we're going to plug in 3 test points. So we have f prime of -1. So that one's going to be a 2 times -1 minus 12 times -1 squared. So this is going to be a -2. All right, and -2 minus a big number, right? So that's going to turn out to be negative. So this is a negative. And then the next one's going to be 1 over 10. So we get 2 times 1 over 10 minus 12 times 1 over 10 squared. So this is 2 over 10. So that's a 1 over 5 minus 12 over 100. So 12 over 100. So if we multiply that, then we get 20 over 100 there. So that'll definitely be a positive number. Okay, so now we switched over to the positive, and our last point is going to be f prime of 1. So that's going to be 2 times 1 minus 12 times 1, basically. So that'll be a negative again. So now we're back into the negatives. Okay? So here, let's see what's going on. We have on this interval, so it's divided by the critical point of 0, and this interval is divided by, or defined by 1 over 6. That's a 6. Sorry, I kind of made that really bold. Okay, so this interval here, this is decreasing, right? Our function's decreasing. On this one, it's increasing, and on this interval, it's decreasing again. So here we have decreasing, so it'll be decreasing to increasing, all right? So this is a local minimum, at least, okay? And then on the other hand, this one goes from increasing to decreasing, so rising and then falling, so then it'll be a maximum, okay? So keep this in mind. We will be recalling that later on in the problem after we deal with the second derivative. Okay, so now we have that our second derivative, let's do a refresher here. So our second derivative was equal to 2 minus 24 times x. I don't know why I put parentheses around the x, but we're just going to go with it. Okay, and then our critical point for the second derivative was 1 over 12. Okay, so let's form our sign analysis here. Let's set that up. So we have 1 over 12 going on. That was supposed to be a 12. Okay, there we go. So we can pick just easy points, 0 and 1. So let's plug those guys into the second derivative. So if we have f double prime of x is equal to 2 minus 24 times 0, then we get a positive 2, right? So that's positive, that's good. And then f double prime of 1 is going to be 2 minus 24, basically. So that'll definitely be a negative value. Okay, so let's see what's going on here. Our divider line is at 1 over 12. Okay, that's our critical point. So that defines our interval. Okay, and then for the negative infinity up to 1 over 12 interval, we have concave up. Okay, so concave up. And then for this negative interval, we have concave down. All right, and we see that at 1 over 12, at that x value, the sign of our second derivative does change, right? So we do have this point of inflection there, where their concavity changes. Okay, so now let's put together everything that we have discovered. So our transition points, so the points where either f prime or f double prime changes signs, right? So transition points, so where f prime or f double prime changes signs there. Okay, so this would be at x is equal to 0, 1 over 12, and then 1 over 6, okay? At 0 and 1 over 6, our f prime changed, and then at 1 over 12, our f double prime changes. So these transition points are very important because they define what our intervals are going to be like, okay, when we make our chart, right? So, anyways, so what this means is that what we had is, let's form our chart now. So f prime and f double prime, okay? So we're going to make this chart here, and then we'll make it like that, all right? So here's our interval. This is what we're going to do is, all the way to the left is always a negative infinity, okay? Unless they give you an interval in the problem to work within, like endpoints and everything. But here they didn't, so we're going to say negative infinity up to the leftmost transition point. So that would be 0, okay? And then we draw our line here. So that's the end of one interval. And now we have, we're going to write the next interval, 0 to the next one. So then we have 1 over 12. Okay, so now we're done with 0, and now we're on 1 over 12. And we finish that endpoint, so we're going to draw another line. Okay, and then we start the next interval with 1 over 12, and then we end it at 1 over 6. So we're done with 1 over 12 completely. And now we're at 1 over 6, so 1 over 6, and the rightmost is always infinity, if not told otherwise, right? Not specified. Okay, so we actually have a total of 4 intervals going on here. So let's, I know it's on previous slides, but anyways, I'm going to go back and say that on these intervals, we had certain signs, like positive or negative, for our first derivative and second derivatives on these intervals, okay? That's what we found by sign analysis. So, all the way from negative infinity up to 0, our first derivative was negative, okay? So up to 0, our first derivative was negative. So we're going to write a little negative sign in there, okay? And then at 0, it switched to being positive, okay? So at 0, it switches to be positive, and it stays positive all the way up until our critical point of 1 over 6. So all the way up until here, it's still positive, still positive. The 1 over 12, the switch here, doesn't really matter for the first derivative, okay? So it just stays positive, and then at 1 over 6, we reached a maximum in our function, and then the first derivative changed to become negative, okay? So that's what happened with our first derivative, and now let's look at the second derivative. So according to the sign analysis of our second derivative, the big switch, or the big change, our point of inflection was at 1 over 12. So this line is going to be the most important for our second derivative there. So to the left of 12, 1 over 12, that is, it was positive. Okay, so second derivative positive, 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 and then it switches to become negative, negative, negative. All right. So here you see how we have like 4 different kinds of combinations of, wow, we actually have all different, 4 completely different intervals here. So let's write what each of these signs means. So mean, I guess each of these signs mean. Yeah, that's grammatically correct. Okay, so f prime being negative, that means that our function is decreasing. So it's decreasing here and it's decreasing here. And positive, a positive first derivative means our f prime, or our f of x, our original function, is increasing. Okay. Plus signs, when we're dealing with the second derivative, signify concave up. So we're concave up, concave up, concave down, for negative, concave down. Alright, so let's do a little sketch of what our graph pieces look like now. So we have a decreasing function here. Here I'll make a little, another little column there. Okay, so here we'll make another row actually. Okay, so we have decreasing but concave up. So this is going to look like that. Okay, for this column we have increasing and concave up. So increasing and concave up like that. For the next one we have increasing but concave down. So something like that. Okay, and then for this last one we have decreasing and hold on. Alright, yeah, so increasing and concave down. So something like this. Sorry about that. So we have increasing and concave down, alright, and then we have our decreasing and concave down. So that one looks like this. I was jumping ahead there. Okay, so we have these 4 different graph pieces here, and now what we're going to have to do is simply graph them, right? Okay, so this is what we have. We had something like this, and this was for the interval from negative infinity up to 0, and then from 0 to 112, then we had increasing and concave up, okay? And then from 1 over 12 to 1 over 6, then we have increasing but concave down, so like that. And then from 1 over 6 to positive infinity, we have decreasing and concave down, so like that. Okay, so we have these 4 different pieces here. We're just going to piece them together. So again, our original function was y is equal to x squared minus 4x to the third. Okay, and what we can do here is actually just pull out an x squared. So we get 1 minus 4x. So we see that we have x-intercept at 0 and 1 over 4. Okay, so x-intercept there. So when we draw our graph, we can kind of sketch something like this. So we have x, and then our y, and then we have something like, here's, okay, so this is going to be a little bit tricky because we're dealing with a bunch of fractions, right? So we have our critical point at 0, there's one at 1 over 12, 1 over 6, and then we have to have this 1 over 4 here, okay? So let's draw 1 over 6, okay? So let's say 1 over 6 is here, 1 over 12 is there, that's half of it, right? Half of 1 over 6 is 1 over 12, and then here we have, okay, so that's 1 over 12, 2 over 12, 3 over 12, so 3 over 12 there. So that's the same thing as 1 over 4, right? So this is 1 over 4, that's our point there, 1 over 4. So we have an x-intercept here, and we have an x-intercept at 0. So now we're just going to kind of fit our pieces in here. So everything to the left of 0 and up to 0, that's going to look like this piece here. So we're going to plant this piece right in there. Okay, so it looks like that, decreasing but concave up. All right, the next piece from 0 to 1 over 12, so from here to here, we're going to draw this concave up and increasing. So like that. Okay, that's it for that one. So we finished those 2 pieces, and now we're on to 1 over 12 to 1 over 6. So from there to there, we're going like so. Okay, so we're going to draw a point here, and then it goes up, and it's increasing, but it's concave down. All right, and then at 1 over 6, so we're done with that piece. 1 over 6 to infinity, we're going to just keep going down, down, down. We have to cross through that point as we continue going down. Okay, so that's basically it. That is that's the sketch of our graph, which was given by this function there. All right, so that's it for this video on graph sketching and asymptotes. I hope that helps, and happy studying.
Off RAM and 12 gigawatts, nuclear response once the rhyme is launched. Armageddon starts, snack on all the car body part. If Shawty Yard enters